P4 is not that hard if you know how to do the hard ones. So I decided I should do something a little differently than just walking through a real past paper. Because in the paper, there are easy ones and hard ones. Those hard ones are actually the ones that take marks away from you. So in this video, it's not going to be just for those of you who have the P4 exam coming up this year or next year, but this video is meant to be useful for later generations to come, starting now. So I have compiled the top 2 questions looking across all the P4 papers from 2020 October up until 2025 January. If you think there is any question harder than the ones that I have in this file, just comment, and maybe I'll just make a short explaining that particular question and include the link to the short in the description of this video, so this compilation can grow forever. And again guys, I would like to share not only my knowledge, but also the resources I have here. All I ask from you is a kind subscribe to my channel, and I'll make sure I'll keep posting useful video for you guys to prepare for the exams. So let's dive into it. So let's have a look at the first topic, proof by contradiction. Now, I realize that many of you may ignore this topic because sometimes in some papers there are just 4 marks for this one. But as you can see here, in some years they add more marks. Like from the second question here, January 2023, there are 8 marks for this. So it's probably a good idea to maybe learn more a bit about it and make sure that at least you know how to do these ones. So typically the hard proof question is going to be the rational, irrational related question there. But the first one is a little different. So let's have a look at the first one first. So the first one is from January 2024, question 8. Use proof by contradiction to prove that the curve with equation that has no stationary points, right? So typically we start from the assumption. So assume that, so we just put a negation to the sentence. So we say that the curve with equation y equals 2x plus x squared plus cos x has stationary points, right? Yeah? So that is the assumption. And somehow we know that we expect to contradict this assumption later on. So, well, about stationary points, we are given the function, so we should differentiate, yeah? Because at stationary points, the derivative of the function equals 0. So we do differentiate dy by dx there. So differentiating 2x, we get 2. Differentiating x cubed, we get 3x squared. Differentiating cos, we get a minus sine x there, right? And then we're going to equate this to 0 because that is the gradient at a turning point or stationary point, right? So we need to solve this one, and we need to act like we're trying to solve it. So for example, I might do that. Now this one is tricky actually because there is no way you can solve it by hand. I mean, it's hard to solve it by hand, at least. It's not in the level of, your syllabus here. So we can try use some logic here, i.e. we can consider the ranges of the left-hand side and the right-hand side. If you consider the range of solutions, if you consider the range of values of sine x, it must be in between minus 1 and 1, right? So sine x here has the range, yeah, in between minus 1 and 1. No less than minus 1, no more than 1. Right? But then the 3x squared plus 2, if you consider the x squared is greater than or equals 0. But then if you add 2 to that amount, then it is always greater than 0. In fact, it is always greater than 1. Right? It's like if you plot the graph there, it's going to be a parabola, and the minimum point is 2, isn't it? So that function is always greater than 1. Now, do you see that this already indicates that there will be no solution to x to fit the one that has to be greater than 1 and the other one that has to be in between minus 1 and 1. There is no solution to x there to satisfy both conditions. You know what I mean? Try to understand this bit, right? So it is impossible. So no solution to x, yeah, in this equation. If there is no solution to x into that equation, it means that dy by dx is not 0. It means there are no stationary points. Therefore, no stationary points. Yeah? And that contradicts the assumption that there are stationary points. So we finalize the statement here that the curve with equation blah 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 has no stationary points. And that's it. I'm not gonna write it. Yeah, so it just, you know how to do it, right? So this is not a, you know, thorough walkthrough. It's just so that you kind of like see the hard question and know how to do, right? And then I'm just gonna dot there so that you know what to do next. Just write the concluding statement, right? I'm gonna shrink down a little more. And that's question 1 done. Now question 2 is kind of like maybe a little harder. Student was asked to prove for P is a member of natural number, that is the capital N there, that if P cubed is a multiple of 3, then P must be a multiple of 3. The start of the student's proof by contradiction is shown below. Assumption: there exists a number P where P is a natural number such that P cubed is a multiple of 3 and P is not a multiple of 3. So that's fine, right? Let P equals 3k plus n. Sorry. Let P equals 3k plus 1. K is a natural number. Consider blah, blah, blah. Now, this student has proven that for P equals 3k plus 1, the P cubed end up not being a multiple of 3. Okay? So, question A says, show the calculations and statements that are required to complete the proof. So if we start with P being not being a multiple of 3, right? So if P not a multiple of 3, then what's the possibility? Well, think of this as odd and even. So an odd number is not a multiple of 2. That is why we do 2n plus 1 or 2k plus 1, whatever letter you like, right? For the even, we do 2k. For the odd, we do 2k plus 1. But why is that? Well, of course, you guys know that, okay, odd is like an adjacent number to an even number that comes before it. But you see, the divider to decide whether it's even or odd is 2. So if you have a remainder of 1, let's say you are dividing 11 by 2, right? So you get 5 and remainder 1. When you have a remainder of 1, then it's not a multiple of 2. But now if you want to consider being a multiple of 3 or not, the remainder can be 1 or 2, right? So it's not going to be 3k plus 1, just that anymore. It can be also 3k plus 2 to not be a multiple of 3, right? So this student just proved one case. We need another case, right? So we need P. So I'm just going to copy that template. Let P equals 3k plus 2, where k is a natural number. And then we're just going to copy that step. So consider, yeah, P cubed equals, just going to do 3k plus 2, and then cubed equals, so 27k cubed plus 3k cubed times 2 plus 3k 2 times 2 squared, and then I'm out of space, and then plus here the last term cubed, so which is 8, yeah. And then what do we have? So I'm just going to expand that. 27k cubed plus 927, 54k squared, right? Plus, what is that? 9 times 4, 36k plus 8. So we're going to pull 3 out from all the term. And for the 8, we can split into 6 and 2, right? Because we need to put everything into the big brackets and have a remainder only 1 or 2 to make it not a multiple, right? So this is 3 and then 9k cubed plus 18, right? Yeah, 18k squared plus 12k plus 2 and then plus 2 outside. Yeah, so because this whole thing is an integer or even a natural number, right? So that means this is not a multiple of 3 because there is a remainder 2 there. I mean, if there wasn't the 2 there, then it would have been a multiple of 3. But we didn't want that, did we? We want this to not be a multiple of 3 so that we can contradict this to the assumption that p cubed should be a multiple of 3. But it actually isn't here. All right? So this whole thing contradicts, yeah, the assumption that p cubed is a multiple of 3, right? So we can conclude the original statement that if p cubed is a multiple of 3, then p must be a multiple of 3 also. And that's it. I'm just not going to write the concluding statement. You should when you do this thing. Okay. And that is just part A, guys. We're not done yet because the highlight is actually the next part. Part B, hence proved by contradiction that cube root of 3 is an irrational number. Yeah? So now I'm going to need more space here, right? And make sure you know and you learn how to do this, right? Because this is like the highlight of the proof by contradiction. Yeah? So let's do number 2, part B here. So we're going to assume first, assume that cube root 3 is a rational, just the opposite there, number, right? Okay, so according to the definition of a rational number, we're going to write that thing equals a over b, where a and b are integers, yeah, integers, and and cannot be simplified. You can write cannot be simplified. You cannot. You can write they are in their lowest terms, or you can write they are co-prime. So co-prime means that they don't have a common factor. Anyone would do, from what I said, right? The fact that it is a rational number means that this a over b should be fully simplified. All right? If you fully simplify the thing and a and b are not integers, then this is not a rational number. But we are assuming that it is a rational number, so there you go. Okay, now, when you have a surd here, this is a surd of a cube root, so you're going to make it not a surd, right? To just do what to just see what to do next. Now, if you try cube, yeah, so if it was a square root, you would just square both sides. Now, this time it is a cube root. You just cube both sides. So you cube both sides, you get 3, yeah? And then this will be a cubed over b cubed, right? There you go. And what follows here is kind of like a little tricky and complex because depending on the question, you need to use some like knowledge, prior knowledge about this. In this case, we are using the part A, and you will see. So when we have this, then we can write a cubed equals 3 times b cubed. Can we not? And what is that telling you? Well, because you can write a cubed as a multiple of 3, because that is 3 times an integer, right? So therefore, a is a multiple, and I'm just going to write mul here, of 3. When a cubed is a multiple of 3, using that statement there, because in B, as you can see, there is a hence. So we're going to use this original statement in part A. the fact that p cubed is a multiple of 3, then p must be a multiple of 3. So because here we have a cubed is a multiple of 3, then a, yeah, is a multiple of 3 as well. I'm just going to copy that. So if a is a multiple of 3, then we can write a equals, say, 3 times, I don't know, I'm just going to go with k maybe, where k is a, you know, an integer or a natural number, right? That's it. No, not that's it. I mean, I'm still going, but that's it for a. Now we're going to keep this, right? And we're going to use this, plugging this back into this. And this is the key step here, because after this, if you don't know what to do, you're going to stop here. But because we already got something about a, how about we substitute that back into this to see what happens, right? So we're going to sub that back. 3 equals 3k to the power of 3, and then over b cubed. Now, as you can see, if you cube the brackets there, you get 27k cubed. Yeah? And then if you rearrange, you're going to get what? B cubed equals 20. Well, if you cancel the 3 ones, you get 9k cubed, right? Yeah? And 9k cubed, isn't it just 3 times 3k cubed? Well, isn't that also a multiple of 3? Yeah, so we can say again that b cubed is a mul of 3 again. And we are repeating the steps here. So b is also a mul of 3. So we can write also b equals 3 times m maybe. I'm going to use m, where m is another integer, not to be confused with the k. Now we got a to be 3k and b to be 3m. Now if you put that back into the original cube root of 3, you will see that the 3 is the common factor. Well, what's wrong with that? Of course, there is 100% something wrong with that, because that cannot be a rational number then. So if you plug that back in, you get 3k over 3m. And 3k over 3m can be simplified. We're going to stop from 3k over 3m here. Yeah? This, so that means a and b are not in their lowest term. Right? Or they can be simplified now. Right? Because we get 3 and 3, so they can be simplified. So that goes against the original assumption that they are co-prime or cannot be simplified. So we just write this contradicts the assumption, and hence the original statement is cube root 3 of 3 is an irrational number. This is classic. There are about 3 or 4 questions like this in the past papers, I've noticed, but this one is kind of like more complex because you need part A to do part B. So there you go. I think this is the best one, and you should know how to do it. All right. Okay, so that's it for the proof by contradiction. Again, if you think you've seen any harder one, just comment, and I'll make sure I'll include it in the description. Right? Partial fractions. Well, this topic is not too bad because usually it is part of other topic like integration. So after you do partial fractions, you can see that you might have to use it to integrate later on. So the first one is from October 2021, question 3a, just a part of that question, because this is just partial fractions and not integration, right? Okay, so yeah, it's not too hard. It's okay. I think this topic is okay. You shouldn't lose marks for this topic. But if I were to pick some hard ones, well, maybe these two are the hardest ones. All right. If you see any harder one, just give me a comment. Okay. So gx equals blah blah blah, and then it already tells you the form, right? So when the leading power of the numerator is greater than that of the denominator have a leading power of 2 here, because if you expand, you're going to get a quadratic. So you need to do a long division first, maybe, for this one. And that makes this a little more complex than the other ones, right? So we're going to do a long division first. So I'm just going to expand the denominator. I get x squared plus 3x. And then we're going to do that, yeah? 3x squared plus 3x cubed plus 8x squared minus 3x minus 6. The first one divided to the first one, we get 3. Yeah, wait, hang on, this is 3. Okay, let me write that again. Yeah, so the first one is 3x actually. So we get 3x cubed here, and then 3x multiplied 3x, we get plus 9x squared. All right, and then we subtract, so 3x cubed goes away, we get minus x squared here, pulling the 3x down. The first one divided into the first one again, we get minus 1. Yeah, so this becomes minus x squared and then minus 3x. Okay, so that vanishes, and then we pull the minus 6 down. Yeah, so that is just minus 6 on the last row, which is actually the remainder, because we can't really divide the x squared into the 6 now, because the degree is less for the minus 6 compared to the x squared. So that means the remainder is minus 6. So that's just the first step, right? That's just the first step. So let me just shrink this down a bit. Yeah. And then what do we do next? Well, we take this as the quotient. Sorry, that as the divider. This instead is the quotient. So this will match to the ax plus b, right? So it would be 3x minus 1 for the a and the b, yeah? You got to know that, yeah? And then we don't have the c and the d yet, but then we have this. It's a minus or a plus minus 6 divided by the divider, which is x squared plus 3, which was actually x times x plus 3, because we expanded from that. So you see the minus 6 over x times x plus 3 here will make two partial fractions, c and d there. All right, you should see this, yeah, before you go to the exam. So we're just gonna do separately the partial fractions for that particular algebraic fraction there. So you go like, well, you see, if you just take this and equate that to, you know, c over x plus d over x plus 3, and then the rest will just be easy, right? So I'm just going to be relatively quick here, and then I do x plus 3 times the c and then d times the x here. So maybe I'll go like, if x equals 0 first, we have minus 6 equals 3c, so c equals minus 2. And then I go like x equals minus 3, and then minus 6 equals, so the c goes away, we have a minus 3d. So d equals 2. Now we get the c and the d, yeah? So we can conclude that a equals 3, b equals minus 1, c equals minus 2, and d equals 2. That would be the end of that. All right? Yeah, make sure you understand this. And if you don't, maybe you can give me a comment there. I'll make sure I'll reply. Okay, that is just the end of the first one. Okay, number 2. That's number 1 there. Now the next one is from January 2024, question 2, part A again. Okay, so this one you should see is just a repeated root. The way to do this is to multiply by all of that you see in the denominator part of the left-hand side. So I'm saying you just multiply this whole bit to every term and see what is left on each term. That's just the way to go, really. Okay? So if we multiply all that, of course, the left-hand side will have no denominator. I've seen some students actually get confused with this. Like they have different bits on each term, right? So you make sure you understand this, right? And then equal. So for the a, if we multiply by the lowest common multiple or the denominator on the left part, yeah, simply, then the x minus 2 will cancel. What you have left is just 2x plus 1 squared, right? And then for the b, because you don't have any x plus 2 there will be x minus 2, one of the x minus 2, and then one of the 2x plus 1 goes away, so you have one of them left. And for the c, because you cancel both of the 2x plus 1, so you will have left the x minus 2 brackets. Let me move that to the left a bit. Yeah. And there you just take the critical values for all the brackets, doing separately, just like I did in number 1 there. So let's take x equals 2 first, maybe. So if x equals 2, b and c will disappear. So we have 2 times 3 is 6, 6 plus 4 is 10, right? And then 10 equals, so we are only having the a term there. 2 times 2 is 4, and then 4 plus 1 is 5. 5 squared is 25, so that's 25a. So that a is just 10 divided by 25, which simplifies to 2 over 5. Yeah? Just going to move to the left a bit because I'm blocking it. And then the next one is x equals 1 over 2. No, minus 1 over 2, yeah? All right? So the a and the b will disappear, left with the c. Let's substitute minus 1 over 2 into the left side, so we get minus 3 over 2 plus 4. Minus 3 over 2 is like minus 1.5, so that's 2.5. 2.5 is 5 over 2, yeah, equals, and then the c, right? So minus 1 over 2 minus 2, so that's minus 2.5, which is minus 5 over 2 again, c. So clearly c is minus 1, right? Okay, I'm just checking. Yeah. And then x equals, well, if you are out of critical values, you just go whatever value you want. So in this case, I just go with 0 because usually it simplifies the left-hand side, okay, and also the right-hand side. So if x equals 0, the left-hand side would just be 4, and then you would have 1a there, because if you sub in the 2x plus 1 squared, and then you would have how many b's? So that's minus 2 times 1 is minus 2b, right? And then minus 2c, yeah? So we need the b here, so b would just be equal to a minus 2c over 4, right? Just moving the things there. Oh no, not over 4, over 2. Yep. Wait, hang on, no. Sorry. This is a minus 2c minus 4 over 2, yeah? Okay. So that is a, what is a? A is 2 over 5 minus 2c is, I'm just going to write down, 2 over 5 plus 2, yeah, minus 4, all divided by 2. Let's use a calculator there. 2 over 5 plus 2 minus 4 divided by 2 as a partial fraction, so that's minus 4 over 5. Yeah, so I mean, if I have made an error or something, but the method should be just that, right? A, B, and C. Yeah, so that is done for partial fractions. Yeah, if you have seen any more difficult than this, just give me a comment. Again, we will help this compilation, the video and also the file and the description, become, you know, like growing more and more. So there are more questions to come, right? It's not going to stop just at these 2 questions for this topic. It will keep growing. All right. Now let's have a look at the next topic, coordinate geometry in xy plane. Things like parametric equation here. Yeah. Take this one, June 2021, question 5. A curve has an equation y squared equals y e to the minus 2x minus 3x. A show that dy by dx is that. All right, so this is implicit differentiation here, guys. So the left side there we have 2y and then dy by dx. Okay, and then on the right hand side we're going to do term by term. So the first term seems like it's a product of 2 functions, so you got to be careful there because I think this is where most people went wrong there at the time. So we're going to do u, which is the first term, dv, so differentiating e to the minus 2x, I have minus 2 e to the minus 2x there. Yeah, that's u dv. Plus v du, so v, which is just the exponential term, du, differentiating y, so usually you would get 1 for the x, but then you add dy by dx, so basically it's just dy by dx, yeah? So it's dy by dx times just e to the minus 2x. And don't forget, we have to differentiate the 3x as well, so we get 3, okay? Now, because we need to make a dy by dx the subject by itself or isolated, so we're just going to gather that term. So I'm just going to make it to the left side. So I have here 2y dy by dx, which is just that one, and then minus this guy right here, yeah? It's going to be e to the minus 2x dy by dx, and then equal everything else to the right. So we have minus 2y e to the minus 2x minus 3. And then we're going to just factor dy by dx out and then just move it to the other side, and then we have it there. So this is just 2y e to the minus 2x minus 3 divided by, so if we factor dy by dx out on the left, we would get 2y minus e to the minus 2x inside, and then we move it to the right part at the bottom, we have this, right? And of course, it's not exactly the same yet, because as you can see, like all the signs flip here. So if I kind of like multiply by minus 1 over minus 1, is like multiplying by minus 1 on top and bottom. You're going to, of course, get 2y e to the minus 2x plus 3 there, because all the signs should flip. And then that is just swapping there. So you get that, right? So that is just as required. So part B, the curve crosses the y-axis at the origin and at point P. Yeah, so this is actually the part A is kind of fine, but the part B here might be more difficult, yeah? The curve crosses the y-axis at the origin and at point P. And now then later it says the tangent to the curve at origin and the one at point P meet at point R. And then we want to find where they meet, basically, right? But we don't have any idea about point P yet. So we're going to find point P first. So point P is when you sub, because they cross at the y-axis there, so we sub x equals 0 first to find where point P is on the y-axis, right? So we sub x equals 0 into this function, yeah, so we get y squared equals y e to the 0, right, is 1, so I'm not going to write 3 times 0 is also 0, so I'm just getting that, basically. So this is basically what? Y minus 1. If you move everything to the left, you have y squared minus y equals 0, and you factorize into y times y minus 1. So the y will be just 0 and 1. And that kind of like makes sense because you have intersecting at origin and point P. So the P coordinates would be 0 and 1, because the other one is 0 and 0, which is the origin, yeah, because we have 1 here, yeah. So that is point P. Now we need to find the gradients of the lines in order to find the linear equations of both lines. So the gradient, yeah, at origin, which is O here, would be just subbing x0 and y0 into the dy by dx that we get earlier. I'm just going to use this one then. So 2, 0, 2 times 0, and then e to the 0 plus 3 divided by e to the 0 plus minus 0. So we get what? 2 times 0 is 0, so the first term vanishes. We get 3, just 3. Yeah? So because it is at the origin, it doesn't have a y-intercept. So the equation of this one is just y equals 3x. Because c is 0, because it passes origin. Make sense? Now the other one is just dy by dx at point P. Yeah? So at point P, yeah, making sure that it's a tangent, not a normal there. It's tangent and tangent. So at point P, you just sub what? X equals 0 and y equals 1, right? So x equals 0, y equals 1, so 2 times y here. And then x equals 0, e to the 0, plus 3. Gotta be careful, guys. And then x equals 0 again, so that's e to the 0. And then minus 2 times 1, because y is 1 there. So we have 2 plus 3 is 5, and the bottom is just minus 1, so that's minus 5, right? Let me double check, yeah? 5 on top, and then e to the 0 is 1. And you have 2 times 1, yeah? Yeah, I'm happy with that. So this is going to be the gradient of the other linear equation. Yeah, so we're going to just do y minus y1. I'm just going to take the coordinates of point P here to form a linear equation. So the y1 would be 1, and then m, which is minus 5, x minus x1 is 0, so just 5x basically. I'm just going to write for the working. Yeah. So here we have y equals minus 5x plus 1. All right. And then we're going to solve for point R there just by equating the two equations. I mean the expression of y for the two equations, right? And that would be the last step, guys. Yeah. So minus 5x plus 1 equals 3x, right? So 1 equals 8x. That means x equals 1 over 8. Yeah. And that's the x coordinate of R. So that means y would be equal to, well, subbing into this one might be easier. So it's just 3 over 8. Yeah. So I can write R, yeah, as an answer there, 1 over 8 and 3 over 8 there. So that is just it for the first question. Should be relatively hard. Okay, next. The second one here from October 2020. Question 4. All right. Figure 2 shows a sketch of part of the curve with parametric equations. Yeah. Blah, blah, blah. The curve cuts the x-axis at the origin and at point A. Yeah, you can see from the graph there, although it's quite small. As shown in figure 2. A, find the coordinates of A and show that B has coordinates 20, 0. Basically, just find both of them, right? And as we can see that A and B are on the y-axis, sorry, x-axis, that means y is 0, right? So part A, if we put y 0, so we're going to have 0. We take the parametric equation here, equals t cubed minus 4t, okay? Just to get the method mark there. So that means if we factorize t out, we get t squared minus 4 equals 0 here. Yeah. And then, well, that is just a difference of squares, t squared and 2 squared, right? So it's t squared minus 2 squared. So it's t plus 2 and t minus 2. Yeah, if you know that, it's faster, guys. That's it. All right. Well, so that means the answers to t would be, yeah, 3 of them, 0, minus 2, and 2. To get the x values, we need to plug it in here, right? So x of the first one is just, so I'm just going to write at t equals 0, x is 0. So that's the origin. At t equals minus 2, x is what? Minus 2 squared is 4, 4 times 2 is 8, and then 8 plus 12, which is 20 here, okay? And then when t equals 2, that would be still 8 minus 12, which is minus 4, all right? Yeah, so this is, of course, point B, indeed. Yeah, that's point B because we get x as 20. So point A would be when x equals minus 4 here, it should be around here, yeah? Yeah, so that is when x is minus 4, of course. So that's we're going to take as point A because it's the only one. All right, so that's the first part done. Not too bad, yeah? Okay, I'm going to shrink again just to keep everything on the same page. And then part B. It asks you to show that the tangent equation at B is that. So at B, we have a point of 20, 0, but we haven't got the gradient because to find the tangent equation, we need the gradient of the line, right? So we can find the gradient, of course, by doing parametric differentiation, right? So parametric differentiation is just dy by dx equals dy by dt over dx by dt. Yeah, this is not too bad. So dy by dt is, you know, differentiating that guy, we get 3t squared minus 4. Yeah. And then differentiating the x equation there, we get 4t minus 6, right? So far so good, yeah? And then at b, right, we can sub t as being minus 2 because we got it from here, because that's for point b. So t must be minus 2. That means when t is minus 2, dy by dx will be equal, just gonna write better again. So just subbing that in. Yeah, what do we get? 3 times 4, 12, minus 4 is 8, 8 over, minus 8 minus 6 is minus 14. So that is basically minus 2 over 7. No, minus 4 over 7. Just double checking that. Yep, okay. And then we need this gradient to form the tangent equation. So we use y minus y1 times mx minus x1. And the x and the y will just be the points, coordinates of point B. So y minus 0 equals m, which is that guy, x minus 20, right? Okay. So we just maybe, because it wants in y, 7y, 4x minus 80, we just multiply everything by 7, so we get 7y here, and then expand the minus 4 into that, we get this. And there you go, we got it. So, like that, as required. Yeah? Happy? Okay, the last part is probably tricky if you don't know what to do. So when it says that this tangent is going to cut the curve again, it's asking you to solve the simultaneous equations between this tangent and the whole parametric equations. The easiest way and most efficient way to do is to sub x into the x and y into the y, like that. So we are solving it simultaneously parametrically. Yeah? Okay, so that is part C. We're just going to write 7 and then you use the expression, parametric expression for the y. So we get t cubed minus 4t plus 4, x is 2t cubed, squared, minus 6t. So while copying the thing down, I always check back if I copy everything correct. That's how to be careful, yeah? And then minus 80 equals 0. And then we're going to solve that equation right there, yeah? So seems like a cubic equation here, no worries. 7t cubed, and then I do the square first, so plus 8t squared. And then I have what for the t? So I have minus 28 and minus 24. That's going to be minus 52t, yeah? And then minus 80. Okay. Now, because we already know that one of them is like, it's like this. If you imagine it's this line. Tangent at B and then cut the curve again. So we are finding the answer of this one right here. Yeah, it's that one right there. So we know that they meet at about 2 points, and one of them is point B. So we know that the answer to this must be, one of them must be minus 2, because that is of point B. Make sense? You can use a calculator, but you know, you should know that too, right? So we expect one solution to be at point B. So we know that we can factorize into t plus 2, because that would give a critical value or a solution to t as minus 2, and then this will be a quadratic factor, right? So at squared plus bt plus c equals 0. I have an a there because there is a 7 there. So a is definitely 7 here, guys. Do you see that? Yeah? I'm going to move the thing to the right a bit. Yeah? This is definitely 7, the a, I mean. So I can just write a as 7 already. I mean, you can do long division, but this also works, yeah? And think about the c. What should the c be? The c should be, you know, if you multiply the last and the last term between two brackets, they should give you minus 80. So the c should be minus 40, right? Yeah? And then how do we deal with the b? Well, we just pick this term here, or maybe the squared term. Okay, so let's pick the squared term. We have already one of them to be bt, Yeah, so this is b dt squared, and the other one is just 14. Yeah, so we have 14 plus b must be 8. Just comparing coefficients here. Consider term by term. Yeah, so if we pair up the multiplications that give the t squared terms, there are just 2 of them here. One is from 2 times 7t squared, which is 14, I wrote there. And the other one is t times bt, yeah, which is the b there, should be equal 8. So b is just minus 6, right? So b is just minus 6. Yeah? So we're just going to put minus 6 there, right? I mean, you should write some more working here, all right? But I'm just out of space. And then we solve for the other solutions because we already know that minus 2 we don't want, all right? So what is it going to be? So we do, well, for this, we can also use a calculator, or I can try factorize it. Let's see. So 7t there, and then t. What do we have? 4 and 10? 4 and 10, no. 4, 10, and 4, no. How about 20 and 2? Yeah, 20 and 2. So I get 20 here and 2 here. And this is a minus, this is a plus. That works, right, guys? Yeah, just nailed it. All right. So my t here would be minus 2, 20 over 7, and then minus 2 again. Yeah, because that is where they sort of like touch. That's why it's a repeated answer here. That's fine. So definitely it's 7 over 20. And we want the x coordinate of p. So we just plug that into the x equation, parametric expression there. Okay, so that's just part C. And now we are at the end. So x of p would be just subbing in 2 times 20 over 7 squared minus 6, 20 over 7. Yeah, I'm going to use a calculator for that. Seems like we need exact answer for that. 2 times 20 over 7 squared minus 6 times 20 over 7. No, 7. Yeah? Okay, so that's minus 40 over 49. That would be the x coordinate of p, right? Yeah. Yeah, I'm just gonna not block the screen for the time being, just for you so that you can absorb. Yeah. And that is just it for this one, right? And it for the topic. So let's move on. Next, binomial expansion. This one is very good actually, and not that easy. It's pretty long and not a very typical one. The typical one would ask you to expand, and then I don't know, maybe give the form and then ask you about the validity. Maybe you should also know how to do that, like the range of x where the binomial expansion is valid. But this one is a little different, right? So find the first 4 terms of the binomial expansion in the ascending powers of x, and there you go. And again, every time you do binomial, you gotta make the first term 1 first, and this is 1 over 4, not 1. So we gotta take what out? Minus 1 over 4 out, right? So you need to take part A, you need to take 1 over 4 out first, and that would become 1, and that would become what? 2, right? I mean, you just work backwards if you are not happy with that. So if you multiply 1 over 4 back in, you get 1/2. And don't forget to, okay, you ignore the power first. So when you take a factor out, and then you just add like a, the same power to the expansion there, which is minus 3 over 2 in this case. And they are multiplying here, and this is also to the minus 3 over 2. Yeah, that's just the first line there. Okay, and what is this guy? So it's, let me just calculate it here. 1 over 4 to the power of minus 3 over 2. That's 8, all right. So this is equal 8 times, now binomial expansion. Well, let me check again. Yeah. Well, it's just 1 plus nx. So n is minus 3 over 2, x is minus 2x, yeah, plus n times n minus 1, which is minus 5 over 2, and then divided by 2 factorial times minus 2x squared, second term squared, first 4 terms. So we still have to keep going. Just gonna move everything, yeah, and then plus, yeah, so we have minus 3 over 2, minus 5 over 2, and minus 7 over 2. Just go by 2 to 2 there, because the denominator is 2. Divided by 3 factorial, which we know that it is actually 6. Still need more space there. Times the second term to the power of 3 now, right? And then that is my brackets there. Okay. Might get a little messy here now, but I can shrink it down later on. Okay, so here is equal to, so we're gonna expand that already, yeah? So 8 into that, don't forget I have an 8 there, and then minus 3 over 2 times minus 2 is just gonna give me 3. Multiplying 8, I get 24. I'm gonna simplify everything already here, yeah? And then what about this one? I have 2 of the 2's there, cancel the fraction here, and then it's just 15 over 2 with no negative sign, and multiply 8, I get 60, yeah, so this is 60x squared. Okay, just checking. Yep, happy with that. And then the last one would be, okay, I have 3 over the 2's there, which is convenient because they cancel here. And then I have what? 3 there, cancel. The 2 here from the factorial will cancel with 8. I get 4. So it's 4 times 5 times 7. So that's 140. 140x cubed. That's it for me. Double checking. Oh yeah, all the signs will become a positive there because you have an even number of negative signs. And then I have 3 cut here, 2 cut here. So yeah, I'm happy with that. So that's it for the part A. 5 marks, not that bad. Okay, let's shrink down a bit. Here we go. Part A, right? And then part B. Given that, okay, so this looks a little intriguing. Write down the value of n. So if we take some observation here, this is just that, right? So we want to multiply, or we want to figure out the value of n so that when these two multiply, we get that. Well, that's easy, right? We just do like n plus minus 3 over 2 equals 1 over 2 because they all have the same base, right? Which is my name there. Nice to meet you. And then n here is just, 3 over 2 plus 1 over 2 is just 2. Yeah, easy peasy. I mean, they say write down, but okay. I'm just showing you how to calculate that. Yeah. So far so good, yeah? All right. So, and C, hence. So that's like a hint. You're going to use from part B maybe. So hence find the first 3 terms of the binomial expansion, giving each term in simplest form. So this one is just that, right? Yeah. So we are doing like, 1 over 4 minus 1 over 2x to the power of 2, right? And then the expansion we have, because this guy comes from the first part, which is 8 plus 20. Ooh, looking back, I forgot the x here. Here, all right, just attention mechanism there. 24x plus 60x squared plus 140x cubed. Yeah, so that is it. Just use the expression there because they give you a hint there. Why not use it, right? Oh, I forgot the x again. X here. See, when I'm done finishing one line, when I'm done with one line, I just check everything. Yeah, if I'm still happy with everything. And you should do that too. It's gonna take some time at first, but if you get used to doing this, it's gonna be fast and efficient. You don't need to go double check everything after you've finished the whole thing. That would take some time, if you know what I mean. Yeah, you should try do like this. Okay, so we're just gonna expand out. So I have to do 1 over 16 minus 2 times the first times the second. So 2 times 1 over 4 is 1 over 2. 1 over 2 times 1 over 4. So 1 over 4x, right? Yeah. And then plus 1 over 4x squared. And then now we can expand that. Yeah. Yeah. Okay. So we want just the first 3 terms. So that's just the constant term, the x term, and the x squared term. Yeah. So if we expand the first term to the first term, we're going to get the constant term, right? So that's going to be 1 over 16 times 8. Is there any more constant term? I don't think so. And then the next one would be 1 over 16 times 24x. That's going to give you the x term. And also minus 1 over 4x times 8 here. So we have 2 pairs there. So this is plus 1 over 16 times 24. And then that's the times there. 24. And then plus minus 1 over 4 times 8. And that's the x term, right? And then the x squared term, I'm going to just do down here. So the x squared term, you have more pairs because you can do 1 over 16 times this minus 1 over 4x times this and 1 over 4x squared times this, right? So there are 1 over 16 times 60 plus minus 1 over 4 times 24 and then plus 1 over 4 times 8, and all that is for the x squared term. And if you simplify all that, let me just shrink down again. So the first term is just 1 over 2, right? 1 over 2 here for the constant term, 8 over 16. Well, what is this? Let me just use a calculator there. 24 over 16 minus 2, right? Yeah. 24 over 16 minus 2. So that is just minus 1 over 2x. And then the x squared term, right? It's going to be 60 over 16 minus 24 over 4. And then, yeah, plus 2. Yeah, because 8 over 4. And that is going to be minus 1 over 4 x squared. And I think that's it for this one. Yeah, giving each term in simplest form. Okay, so that's the answer. Now this is from June 2022, question 1. The binomial expansion 3 plus kx to the power of minus 2, where k is a non-zero constant, may be written in the form of that, where a, b, c, d are constants. Find the value of a. Well, the value of a is quite simple. So it's basically just 3 to the minus 2, guys. But we can start from, taking 3 out to the minus 2. And then this is 1 plus k over 3x to the minus 2, right? And then a should be just 3 to the minus 2 times that. Okay, so a is just 3 to the minus 2, which is 1 over 9. That's just it for a. Yeah, I start from there first so that I can expand it later. And we're going to use that expression there in a. Given that c equals 3b, show that, yeah, blah, blah, blah. So basically, I think we have to expand. C is the third term, b is the second term. So the second term is b equals, so when you expand, imagine you're going to have 3 to the minus 2 multiplying outside, which is 1 over 9. And then the thing inside the expansion, after you get it, would be what? So it's n, which is minus 2. This is the second term, so it's still nx, right? So minus 2 times nx, which is k over 3 times x there. So I'm just going to cut x out, and that's it. Yeah, so it's 1 plus nx, and n is minus 2, and the x is actually k over 3x, but we are cutting the x out because we just want the coefficient. Yeah, so that is just b. So let me just simplify. This is minus 2k over 27, right? And then what is the c? The c is the third term, right, which is the x squared term. So we have n times n minus 1, which is minus 3, divided by 2 factorial, and then this is squared. Yeah, okay, so that is just 2 cutting 2 up there, so we get plus, and this is k squared over 3, right, because one of the 3's cancel above there, and then you get 3 at the bottom, just one of them at the bottom, and then that's it. So we use the equation here, c equals 3b, so k squared over 3 equals 3 of the b, which is this. There you go, just equate them like that. Multiplying out by 3, this is 9, multiplying out by 3, I get k squared equals minus 6k. So k squared plus 6k equals 0 as required. Okay, so that's just part B. Part C now, hence solve for k and d. Yeah, we got it already, k back then. So k and k plus 6 equals 0. That means k equals 0 and minus 6. So we reject the 0 because it's a non-zero constant. So k is minus 6. That's just part I done, right? So part II, we will need to use that k of minus 6 to solve for the value of d. Now, the value of d comes from the fourth term of the binomial expansion. And the fourth term is the x cubed term. So how do we get that one? Well, because we already did for the third term, which is here. And don't forget that we also have the 1 over 9 multiply there. So this is the coefficient of the fourth term, d, being 1 over 9 there. And then the expansion term would be minus 2 times minus 3 times minus 4. Or divided by 3 factorial, which is 6. And then multiply k over 3 to the power of 3, right? So I'm just going to use a calculator to calculate all that, yeah? So we have 1 over 9 times, 2 times 3 times 4. And then the k is just minus 6, right? Now, if we consider the signs, there are 3 negatives from the minus 2, minus 3, and minus 4. And there are other 3 negatives in the brackets because k is minus 6. So they all cancel to positive. So I'm not going to put any minus sign there. And now knowing that this is 6 to the power of 3 divided by, so we already have the 9 there. So the 6 down here and also the 27 down there from the 3 cubed. And that is just it. So the constant d is just then 32 over 9, right? Yeah, let me check again. Yep. Okay, so that's it for binomial expansion. And again, if you've seen any harder one than this, just comment. And I'll make sure I'll include the walkthrough video for that particular one and put it in the description. Differentiation. All right, so this is, first one is October 2021. All right, it seems interesting here. Well, it's probably not that bad. Again, if you see anything harder than this, just tell me. But I think the second one is probably harder. But let's do the first one first. The curve C has equation that the point 3, 2 lies on C. Find the equation of normal to C at the point P. That's it. So that's not too bad, right? It's just typical that you should know. It doesn't just ask you to differentiate, but it also asks you to incorporate that into the coordinate geometry. Okay, we're going to differentiate implicitly. So that's just differentiating the first term, we get 2. Sorry, that's the first question there. We get 2, and then minus differentiating 4y squared. Again, we get 8y, and just adding dy by dx in there. All right. Now, differentiating this one, most people probably forgot to do product rule at the time there, right? So we're going to not forget that. So plus u dv, so u is that, dv is dy by dx. So I'm making 3x squared as a u and y as a v there. This is u dv plus v, which is the y, du. So differentiating 3x squared, I get 6x and just y, because that's the v. Differentiating the right side, I get 8x, and 8 goes away, right? And then we're going to rearrange for the dy by dx because we want it later on. So I'm just going to gather these terms, rearranging to make it nicer, and factor dy by dx out. And by nicer, I mean writing the positive first, after, followed by a negative term. Yeah, and everything else will be shifted to the right. So we have 8x minus 6xy minus 2. Yeah. Okay. So dy by dx is just all that divided by 3x squared minus 8y. And then at point P, we just sub in. But it wants the normal. We note that it wants the normal, so be careful. So dy by dx at point P, I just write that notation, yeah? So this is going to be 8 times 3 here, minus 6 times 3 times 2, just subbing in everything, divided by 3 times 3 squared minus 8 times 2. Yeah? So mental math, 24 minus 36, that's minus 12, minus 14. 27 minus 16, that is 11. Interesting. The gradient of the normal is then just flipping the fraction, putting the negative, so we get a positive there. All right. And then we just form y minus y1, which is 2, equals m x minus x1, which is 3. Just using this point to find the linear equation. Multiplying out by 14 across, I get that. 14y minus 28 equals, multiplying 11 inside, I get 11x minus 33. And then just rearranging, tidy up, moving everything to the same side, we get 11x. I'm going to move y to the other side there, minus 14y, and moving this to the other side, and minus 5 equals 0. Yeah? And that is just it, the answer. The next question, number 2, taken from October 2020, question 5. This is a 5 marker. Well, actually, it's a 7 marker, the whole thing. The curve C has equation that. Now, this one is quite rare because probably is the only one question asking you to do it like this. By firstly taking natural logarithms and find the expression for dy by dx, right? So taking natural logarithm, so it's just ln y equals ln of x to the sine x, yeah? Like that. And then we're going to use the log property to bring the sine x down. So we have a product of sine x and ln x. And you guessed it, we're going to differentiate implicitly. And that is the key here. So differentiating ln y taken as if it was an x, but then after doing that, we do dy by dx. So differentiating ln x, you get 1 over x, but you're doing it to y, so you have to add dy by dx, yeah? And then the next part, well, as a product rule there, so it's a very good blend here. That's why I took it into this compilation. So u dv, so sine x first, dv is differentiating ln x, we get 1 over x, yeah? Plus v du, so v is the ln x, du, differentiating sine, we get a cos, so this is a cos x, ln x. All right? And then, what is this? So we're just going to find the expression of dy by dx. All right, so we just make it the subject, basically. We just pull y to the other side. We have y, and then everything. Just write everything down. Just going to do cos x, ln x, like that. Yeah, I think I'm happy with that. Gonna stop there. And then the last part, we just have to show that that is the solution. So we're going to set, if you write, hence show that the x coordinates of the stationary point, yeah, of C are solutions of the equation. Basically, we're going to set dy by dx equals 0. And that is to set this whole guy equals 0, right? Yeah, that whole guy. So because y is greater than 0, so that is not a worry. We can cancel the y out because the other side is 0. That's a win. And then after you do that, you can move. Imagine you don't have any y now. You only have these two terms. You can move one term to the left. So you're going to get a negative sine x over x equals cos x ln x, like that. Now if I pull x to the other side and move cos x down, yeah, I'm going to get minus sine x here divided by cos x equals x ln x, right? And there you see is at minus 10x, yeah? So I'm just going to shrink everything again. So this is a minus 10x equals x ln x. And if you see we want 10x and x ln x on the same side, so that is just as required. So 10x plus x ln x equals 0 as required there. Yeah, just running out of space there. Okay, and that's it. That's as required. Okay, and that is it for differentiation. Again, any harder than this, just suggest me by commenting. Now let's do rates of change. This is actually in differentiation, but it's a hard subtopic here that I would like to maybe separate from the, like the main list, the main topics there. So let's have a look at this one. This is from P4 October 2024, quite recent. Figure 3 shows a container in the shape of a hollow inverted right circular cone. The height of the container is 30 centimeters. Yeah, just look at the diagram there. I hope you can see it. And the radius is 12, as shown in figure 3. The container is initially empty when the water starts flowing into it. Yeah, so that is just telling you that when t equals 0, volume is 0, right? When the height of the water is h cm, the surface of the water has a radius r, and the volume of the water is v. Now we're just going to show that v equals that. When you are asked to prove the volume of a geometry, or anything about a geometry, particularly in rates of change, you gotta take some observation here, because the volume is only dependent on h. Well, where does the r go? Yeah, you take the observation there. Where does the r go? Well, it is telling you that maybe you need to eliminate the r, or make r in terms of h and then substitute back into the formula. And we are talking about the formula of the right circular cone there. So part A for number 1, because we use v equals 1/3 pi r squared h. But it's tricky, because how are you going to make r disappear there? Well, this is kind of like basic geometry in, say, IGCSE probably, or GCSE, because if you look at the two triangles here, yeah, it's kind of like subtle. I barely have seen any student who like recall that they need to use a similar triangle from the first glance. But if you have enough experience, maybe, yeah. So there are similar triangles in there. It's the ones with the volume of water here. So the height of water is h, the radius r here, and the one that is like the full cone. So the radius being 12 and the height being 30, right? So these two are similar. So we can say, whatever you want to say there, just as long as it follows the similar triangles principle. So I'm going to do r over 12 equals h over 30. So the ratio from the smaller one to the big one is the same for all sides. And we only deal with the radius and the straight height here. So there you go. We already get now r in terms of h. If we rearrange, so we get r equals, what's that? 4 over. So I'm going to use 6, right? So 2 over 5h to cancel that. Yeah, and that's it. So we're just going to plug that in to the formula. And I mean, if you can't prove this, you can just go to the next step and just use the result from part A. There's no worry there. If you fail to prove, right? So I'm going to plug that in and see if I actually get what they want there. So inside there would be 4 over 25. So that, yeah, so it's 4 over 75. All right. Pi r cubed. Okay, pi h cubed, sorry. And there you go, as required. Now, it would have been more difficult when they don't ask you to prove this first. Yeah, and there are questions like that, I believe, in the past, but I didn't bring it up because it might be before 2020, right? It would have been more difficult there. Could have been if they didn't ask you to prove this first. Okay, now for part B, right? Given the water flows into the container at a constant rate. Now this is also tricky. It gives you the rate, right? But it's a constant rate, and this is the key. Find in centimeter, oh, it should be centimeter. Oh yeah, it's the rate of change in height. So centimeter per second, the rate at which h is changing, exactly 1.5 minutes after water starts flowing into the container. Yeah, so it's 1.5 minutes. Now, well, if you don't know how to make use of that 1.5 minutes, of course, 1.5 minutes is like 90 seconds. But then what? How are you going to do that? Well, it gives you the constant volume rate, which is 2 pi cubic centimeter per second. And it's a constant rate. So that means no matter what time it is, it's going to be remained at 2 pi. Yeah, it's going to be at 2 pi. It's a constant. So you can use that and multiply by the time to see how much volume has been filled, right? Because the rate of volume is constant, so it's like per 1 second you get 2 pi cubic centimeters more. Another second you get another 2 pi cubic centimeters more. So if you have gone by 90 seconds, yeah, the volume will be 90 seconds times 2 pi cubic centimeters. Yeah, so that is 180 pi cubic centimeters. All right. Now, what's the point? Well, of course. Now, let's form the chain rule equation first because we're going to make use of this volume. So what does it ask? Rate of change of height, dH by dt. You're going to, most of the time, utilize a chain rule equation in rates of change questions. So if it wants dH by dt, you're just going to make another parameter involved somehow. And in this case, it should be the v. So dH by dt is dH by dv times dv by dt. You see, I just make the dv get involved. Because if you cancel the dv out, you still get dH by dt. Now what's the point? Because we can't find dH by dt directly. We're going to go on a detour, relying on having the dv there. Why is it dv? Why not r? Because, well, v is more related than r, right? Because we eliminated the r at first, so probably not going to be the r. It's more to the v, right? So it's the only chain rule equation that will help you solve this question. Because we already know, we want to find dH by dt, and we already know dv by dt, that is just 2 pi, isn't it? So the only thing you need to crack here is dH by dv. Yeah? And dH by dv seems to come from the derivative of this. If you differentiate v respect to h, you're going to get dv by dh, and you just flip that. Clear? Okay, so we got a plan. So this is just 1 over dv by dh, and the dv by dt is just 2 pi. Okay? Yeah? So, dv by dh, I'm just going to put here, equals, we're just going to differentiate that volume formula there. So that's going to be, so 4 pi over 75 is all a constant. So you just differentiate the h cubed. So you get 3 times, yeah, 3 bringing down, so you get 12 over 75 pi h squared. And that's it, because there is only a single variable there. So now you see, we need to substitute the h. And here we will need to use the fact that the volume is 180 pi. Because you need to solve the h from there. Right? So let me just bring the whole thing down so that we get the height level at first. So h here is going to be solved by cube root. I'm just solving this equation, rearranging h, yeah? So 70, let me just tidy up a bit. Moving it down a little bit. It's going to be a cube root of 75 times the v, which is 180 pi, yeah, over 4 pi, that's it. Okay, so we're going to try to do that. Maybe we're going to keep the exact form first, if we can. So cube root, and then, wait, that's not cube root. Cube root, fraction, yeah. 75 times 180 pi divided by 4 pi. Wait, what? Divided by 4 pi. Nice. Nice number there, right? Don't you think? Okay. Yeah, I think I'm happy with that. Let me just double check. Yeah. Yeah. Okay, that's good. Yeah, so we're going to substitute the h equals 15 there into this to find the dv by dh first. So dv by dh at h equals 15 is, calculator, so 12 over 75 times pi times 15 squared. What? Squared, sorry. So that's, I'm just going to keep 36 pi, all right? Yeah. And then what do we have? So we have here 1 over 36 pi times 2 pi, right? That seems to be an exact form there. So this is going to give me 1 over 18. Yeah, so that is the rate of change of height in an exact form. So I'm going to keep that cm per s. That is the answer there, guys. And we are done for this one. All right. Next one from P4, October 2022. Also rates of change. A spherical ball of ice of radius 12 is placed into the bucket of water. In the model of the situation, the ball remains spherical as it melts. Okay. T minutes after the ball of ice is placed in the bucket, its radius is r centimeter. Okay. The rate of decrease of the radius of the ball, and here's the key sentence here, is inversely proportional to the square of the radius. Okay, so you guys might say, okay, easy. The rate of change of radius is, part A here, is dr by dt, is proportional. I'm going to write the proportional sign there. Proportional to the square of radius, inversely proportional, sorry, to the square of radius. So we're going to get that. Wait, square of radius is a square, not square root. Yeah. Okay, square of radius. But that is what you guys might miss later. Because when it says the rate of decrease, you have to force the minus sign here. So that you get dr by dt equals minus k over r squared. It is just better to put a minus sign here and not later, because sometimes they ask you to prove into a particular form and then there is already a minus sign somewhere. Okay? Now we're going to find the equation linking r and t. So that means we need to do integration by separation of variable, because this is called a differential equation. Alright, so that's it. That's the thing. Okay? So we separate the variable, so I get r squared here. dr equals minus k dt. Okay? Just moving r squared up left and moving dt up right. I'm going to integrate that both sides. So I get r cubed over 3 equals, this is just minus kt times c maybe. Yeah. Because this is indefinite integration for the time being. Okay. Now what next? Well, we need to find the equation of r linking t, but we are given more information. So for part A, we need to solve k and c completely, right? And to get what's called a particular solution to this problem. Because for the time being, this is now called a general solution, right? Because we don't know the k and the c yet. Now, okay, so the radius of the ball is 6 centimeters after 15 minutes. So yeah, we can plug that in, but we should use the initial condition first. I think I read that before. Hang on. The ball remains spherical as it melts. Oh yeah, a spherical ball of ice radius 12 is placed in the bucket of water. Okay, so that is the initial, because the ball getting smaller and smaller, right? So at t equals 0, r equals 12. Yeah? Just checking units here. Should be fine. So we're gonna get 12 cubed over 3 equals 0 plus c. So that allows us to know the value of c. So c is so one of them is 4. 4 times 1, 4, 4. Just going to use a calculator here. Yeah, so 576. That's a huge value of c, don't you think? Yeah, I think it's fine. Yeah. Yep. Okay. So now we get the value of c, and we're going to plug it in, and we're going to use t equals 15 when r equals 6, right? Another condition there that it gives us. So r equals 6, so 6 cubed over 3 equals minus k times 15 plus the c we just got. And that allows us to solve for k. So k is just, yeah, moving the thing. So we have 6 cubed over 3, and then minus 576. And then I'm gonna divide that by minus 15. Okay, that's a weird k value there. 168 over 5. Okay, gonna keep that. So that means the solution to this equation is r cubed over 3 equals minus 168 over 5 t plus 576. Yeah, that's it. That can be fine. I mean, equation linking r and t doesn't mean you need to make r the subject. Okay, so I think I'm gonna go with that. And let's shrink this down again. Here we go. Okay. For B, find the time taken for the ball of ice to melt completely. Well, that means r equals 0, right? You got to interpret that first. Okay, so when r equals 0, we're going to find the time. So we're just going to have 0 equals minus 168 over 5t plus that. Well, just solve for t there, not that bad, right? So it's just 576 times 5 over 168, right? Just moving the thing there and solve for the equation. Solve for t. So I'm just going to go with, this is what? I'm just going to go with like 17.1 minutes. Yeah, just a 3 sig fix there. Part C. Part C on diagram 1. Yeah, this is the diagram there below. Sketch a graph of r against t. So r is a cubic function. No, actually, if you plot t against r, it's a cubic function. But we plot r against t. Right? So it's like an inverse function, if you like, kind of thing. So if we make t the subject, okay, let's make t the subject first. So if I make t the subject, yeah, so I'm going to have r cubed over 3 minus 576, and then multiply by minus 5 over 168, like that. Yeah? Okay, so what does that give me? So I'm going to have whatever the constant actually. Just going to do that. And you will see the point here. I'm just doing the math first. Now the point here is that when we get t as a subject, we know that it is called a cubic function. But that is only when you plot t against r. Okay, so let's try have a look. That's just my way to go. So if you plot t against r, it's going to look like this, right? So t here, r here. This is easy cubic function because you know that if you only have t equals r cubed, if you have t equals r cubed, you're going to have something like this, right? And if you only take the positive side, it's just going to cut this out. But because we have a negative there, so it's just going to flip this to this. Yeah? Probably an inflection at 0 there. Yeah? Like that. More like that. I hope you get it. And then plus 120, over 7. So it's just going to shift the thing up like that. Now what's the point? The point is when you plot r against t, you just sort of like, if you like, you rotate this axis so that r is now upright and t is on the side. So if you imagine, how about you can look at this as r being the vertical and going towards the right here. So if I draw this will be this axis, and this will be this axis, and you draw it accordingly. So you need to find this point first. The r here, where is the r there? So that r is when, is it when t equals 0? Yeah, which is 12, right? We got that already. That's the point on the y-axis there. So I'm going to draw from this point, which is this point, and it's going to go down like that and down to the t-axis there. So it's going to down like this. Wait. It's going to go down like this. Yeah, like that. Because it's just this part here. Can you imagine that? We're not going to care about this part because r cannot be smaller than 0. And that's it. That's the graph. Because we don't plot this. Well, if we did, it would have been something like this, right? Yeah, something like that. And this is the graph for that. It's like part of the cubic function there. Might be the tricky 1 mark there to get, but there you go there. Yeah? Okay, so that is done for rates of change. I hope that was useful. And again, if you see anything harder than this, just comment. Next and the last topic, integration. Now, this one is really, really nasty, I must say. Okay? You guys, if you guys have seen one of my videos walking through this particular year, I had a problem on this one, like live, because I was running out of time and then I was hesitant to just use like another substitution or reverse chain rule. Was running out of time there. So here is a good opportunity for me to explain it again. Now we're just going to follow the subparts there. A show that the area of R is that. So this is parametric integration. We got x in terms of t, y in terms of t, some trig function there and polynomial there. And then we're going to show that if we want to do parametric integration, we're going to arrive at that form. So we have to know first that this integral y dx, yeah, is going to be the same as integral y dx by dt. Now some students ask me, why do we need to do this? Why not just do this? Well, you can torture yourself and do that, yeah, because they don't give the Cartesian form for you. So y in terms of x. If you want to do this, you need y in terms of x. But because they give you the parametric equations, it is easier to plug in y in terms of t here and differentiate x in terms of t here and integrate it with respect to t. Everything is, having a t here, right? So we're going to do that. So integral y in terms of t, which is sine t, sine 2t, yeah? And then times dx by dt. What is dx by dt? It's just 6t, isn't it? Easy. And then dt, yeah? Wait, dt. Now, the bounds should also be changed. And if you have a look at the form here, seems like it has a cos, but we don't. So it comes from here, the double angle there, because this is all in a single angle, just as t, not the 2t. So we need to find the bounds for t, not for x, and also the double angle there to convert it to a single angle t, right? Now the bounds here is just basically, if you have a look at the graph, the bounds, the limits for x is just 0 and somewhere. So you got to solve that from knowing that this is an x-intercept from the graph. Well, in x-intercept, y is 0, right? So we're going to put y equals 0 equals sine t sine 2t. Mostly, I mean, if you don't know how to solve it, but you should, it's mostly, 0 to pi over 2. And as you can see, but we need to prove first that it is actually 0 and pi over 2, right? So we just equate that, and as you can see, sine t equals 0 here, or sine 2t equals 0, just the answers to those two terms. Well, sine 2t equals 0, right? So we have 2 sine t cos t equals 0. So apart from sine t being 0, we can also cos t is 0. And t is going to be pi over 2 indeed, because cos pi over 2 is 0. Of course, there are also sine t equals 0, and that's 0, or pi, but pi is out of the range. So we're not going to look at pi, it's just 0 and pi over 2. Alright, so I have shown that the bounds for t is indeed 0 to pi over 2. So that is going to be this one, go down here to integral sine t to sine t cos t 6t dt, 0 to pi over 2. And so if we simplify this, 6 times 2 is 12. I'm going to bring 12 out. And then there is a t in front because from this t here, so it's a t here, and then sine is squared, and then cos t is just a single one there, and just limits. So this step should be fine for most of you guys. Yeah, this step should be fine. And that is done for part A as required. Alright? Now the next one is a bit horrendous. Hence, using algebraic integration to find the exact area of R, giving your answer to the form blah blah blah. Alright, so we're going to do it. Okay, so I'm going to shrink this down, bearing in mind that we already got that to be 12 there, the constant k. Okay. Alright, so B, let's go. We're going to integrate that. Now, how do we do that? Well, again, if you haven't checked my video for reverse chain rule in P3, you can use a technique from P3 in P4. And if you do know, you should, because it's going to make things easier. Okay, so do you see that when you have the two functions here, there is one type that is a polynomial function, and there is another group of trigonometric functions. So at first, you're going to need biparts here, because you're going to split t from the other group of trig functions. All right. So we're going to use biparts. So we're going to do u equals t. Yeah. So du is 1, and dv would be sine squared t cos t. Now the problem is, integrating sine squared t cos t is like another integration question, at least in P3, right? So how do you integrate that quickly without having to do much work? Again, check the video. I taught you how to integrate this easily, right? Using what's called a reverse chain rule technique. So you see that differentiating the sign here, you get a cos. So when you differentiate the inner function of a power, the sign here has a power of 2. The inner function is just sine t. When you differentiate sine t and you get something on the side, this is the reverse chain rule. So you gotta try sine cube t over 3. Yeah? Now, because you differentiate sine t and you get exactly cos t, you don't need a correction factor. And of course, I encourage you to check that video. if you want to understand this quickly. So you see, that is just done. I didn't do much work at all. And they don't need you to show any work either. You can check the mark scheme. The mark scheme for this one is very short. So that means it's all under the hood there, what's going on here. So if you don't know the technique, you're in trouble for this one. And that's it. Now we can do by parts, right? So we do, so the thing, I'm just going to put that as R first. Yeah? So R equals UV, so T over 3 times sine cube T minus integral. Yeah? Don't forget I have a 12 here as well. Hang on. Yeah. I have 12 here. Integral sine cube T over 3. And this is a big deal. This is another big deal here. Because you need to integrate sine cubed again. And that is real hard work there. Now, are we in trouble? Not really. Because we know what's called the reverse chain rule again. Now, some of you guys may think, well, how do we apply reverse chain rules? Well, it's not quite straightforward yet. Because you need to manipulate the loop first. Well, let me show you. Yeah? So let me shrink down a bit because I need more space again. Yeah? So just for the sine cube 3, yeah? Let's just do this one separately. Let me just split the third outside, yeah? So if I split the third here and the third here, I get a third here. I get a third here, right? And that would just be 4, isn't it? So I get 4 here instead. All right? Just to make everything tidy. So we are now caring about the integral sine cube T. Let's do that separately, yeah? So how about I split into sine T and 1 minus cos squared T dt? Yeah? Okay? Just for the sake of, ease of integration there, because we can't really integrate sine cubed directly. And if you think you can do sine to the 4 over 4, nope, nada, that's going to be wrong. Okay, don't do that. So I have here integral sine T dt, just split integration here, and a minus, or a plus rather, a minus sine T and cos squared T dt, right? So that is just keeping the minus sign, and you will see why. Some of you already see now that that is just another reverse chain rule integration. Because if you are differentiating the cos, which is the inner function of the square there, you get a minus sign on the side. That applies. The reverse chain rule can be applied. You're differentiating the cos, you get a minus sign. Bingo. So, well, I'm just going to integrate the sine t here already. We get a minus cos, right? And then integrating, because you can differentiate the inner function cos, you get a minus sign. So we try cos cubed, just adding the power by 1, divided by 3. Yeah? And the correction factor, we don't need it, because we differentiate cos, we get directly a minus sign. If you struggle to understand why, just go check the video. I really encourage you to go check the video, because this will make your life a lot easier for this one. And look at the marks, just 5 marks. It's not 8 or 10 or anything, yeah? So if you think you could use substitution, go ahead, be my guest, because you're going to need a lot of more work there for not just this, but also from the very beginning when you integrate these. So you're going to do substitution twice in the same integration question, from the by part even, right? That's horrible. So reverse chain rule is going to help you here. So this is a plus. Now I can plug this in back into the previous R expression there, right? So it's just going to be R equals 4 in the brackets T sine cube T minus, yeah? So that whole thing. So if I put this whole thing to this, I'm going to get a plus cos T and a minus cos cube T over 3, right? And I'm going to have all the bounds to be the same, 0 to pi over 2, right? There you go. So we're just going to sub in the bounds and see what we get. So 4. So sine pi over 2 is 1, so 1 cubed is 1. So the first term is pi over 2. Cos pi over 2 is 0. Cos pi over 2 is 0, so that is just the first one. Minus 4. Sine 0 is 0. Cos 0 is 1. And then cos 0 is 1, so that's minus 1 over 3. That's it. So that's 2 pi minus, so what is that? 1 minus 1/3 is 2/3. 2/3 times 4 is 8 over 3, so that's 2 pi minus 8 over 3. I'm just going to leave my answer at that, yeah? And that will be it for this whole thing. Are we done there? So it's PQ plus P pi plus Q, and they are constant. So yeah, we're fine. All right, so that is a good one, really, and you should know how to do all this, yeah? So this is a hard one. Next, from P4 January 2021, all right? So this is question 7. Okay, this is not nearly as hard as the previous one, but I thought that you should know that this integration technique exists. Because if you look at part A there, we integrate e to the 2x times sine x dx. So I would like to call this like a loop integration, okay? So let me tell you what happens here. Let's say if you don't know about this, right? And okay, how about, of course, this is product of two functions and the functions are different, so usually by parts is the way to go, okay? So we're going to make u equals e to the 2x, so du is 2e to the 2x, and dv would be sine x. So integrate sine x, we get a minus cos x, right? Okay, so far so good. So that would be equal to uv minus e to the 2x cos x, yeah? And minus integral du, which is 2e to the 2x, and then dv, which v, which is minus cos x. So I'm going to be plus here, plus cos x. Okay, see, we have to do another bipart again, right? Another bipart in the biparts. So yeah, let's do that again. So the second bipart, what do we get? So u is e to the 2x again, because if we already made u to be e to the 2x, you should do that again. Otherwise, you will get back to where you were before, which is not what we want. And 2e to the 2x. And then dv here is also a cos x. So integrate cos x, we get a sine x, right? Yeah? So what do we have? Minus e to the 2x cos x plus 2 in brackets uv e to the 2x sine x, yeah, minus integral of du, which is 2e to the 2x, v, which is sine x. Now, if you don't know what's happening here, do you see that I'm just going back to the original problem that I was trying to solve? If you just separate the two out, yeah, do you see that that integral there is exactly the same as the question? And this is classic, actually. This is classic. At least, and it hasn't come up for years. This is from 2021, so 4 years now, right? So if you expand all out, if you write down everything, we were trying to solve this, yeah? And then let me write down everything. It's going to take some time here to write down. So with also expanding out, yeah? So I'm expanding the 2 in, I get a plus and open up the brackets, yeah? And that would be a minus 4 integral e to the 2x sine x dx. So you see, you are trying to solve this, but you have it on both sides. Well, with the minus 4 here. So how about you combine the terms first? Right? That's the way to go. Now, most people will put this as an I. Well, that's no problem, but I mean, we don't need to. Because if you move this whole thing to the left side, they're going to combine. So it's like we want to find it, but then there is the same problem on the other side, so you combine. Yeah, it's like putting it as an x or an I, and then you combine the term. So when you have a -4 here, adding the other side, you have a 5 of them. 5 of the problem you want to solve. Yeah, this is just algebra. Okay, equals minus e to the 2x cos x plus 2e to the 2x sin x. And then of course, the problem you want to solve, if you make it the subject, you just divide the whole thing on the right by 5. There, you solve it. Here. Because this is the thing we want. And of course, we just have a plus c there. So this is just plus c as well. Because this is indefinite integration. That's it. That's done. All right? That is just it for me, for this one. Okay. 5 marks. Only when you know how to do it, it's easy. Yeah? There you go. The finite region R is bounded by the curve and the x-axis and is shown shaded in figure 2. There you go. Show that the exact area is R. Well, we're just gonna just sub in the bounds there actually. But we haven't got the lower and the upper limit. The lower limit is of course the x equals 0 here. But the upper limit, we haven't got it. So we need to solve. Well, because we know that that happens at y equals 0, we're going to find the value of x there. So part B, we do e to the 2x sin x equals 0. E to the 2x cannot be 0 anyway, so the answers will come from the sin x equals 0. Right? So x equals 0, or sine of what angle equals 0? Well, that's pi, right? So pi. Sine pi equals 0. That's the second smallest value. Okay. So it's just going to be pi there because this seems like the smallest answer and this is the second smallest. So we're going to sub the bounds. So the area R here is going to be equal to that integral we just got. Yeah. Just going to put 1 over 5 outside here. All right. Because this is definite integration now because there are bounds, so we can ignore the c. 0 to pi. All right. Okay, so 1 over 5, subbing pi in, so cos pi is -1, so this is just minus e to the 2 pi, well, times a cos pi -1, so that becomes a plus. Sin pi is 0, so the second term disappears for the first set of upper limit there, for the upper limit. And then this is going to be minus, yeah, subbing 0 in, again cos pi will be 1, so that's going to be minus e to the 0, which is 1, right? This whole thing is 1. Okay? And then, yeah, I'm just going to put brackets in there. And then sub 0 into the sign, well, that disappears, so it's just this. So then it is e to the 2 pi plus 1 over 5 as required, right? That's it. And that is everything. Integration. And of course, again, if you see anything harder than this for integration, just comment, right? We're going to make this like the very comprehensive compilation of all P4 hard questions, right? Okay, next topic, vectors. Right. A lot of people have problems with this topic. So I have picked this one, the very recent one, January 2025. Because I thought, well, there was a peak in the graph there in the YouTube analytics, and I see a lot of people paid attention to this question that I walked through for this paper. So let's go. Relative to a fixed origin, the line L has that equation where lambda is a scalar parameter. The point A and the point B lie on the line L, given that A has coordinates that and B has coordinates that. Find the value of A and the value of B. Well, okay, part A. So, because point A and point B both lie on the line, so we can equate the coordinates. Because the coordinates of point A is actually going to form the position vector of A. And the position vector of A is on the line. So that means we can equate minus 2A4 to the expression of the vector equation there itself. Yeah, I'm gonna merge the lambda, right? So this is plus 4 lambda, this is plus 2 lambda, this is minus lambda. So we can solve for lambda and then we can solve for A, right? So we're gonna take from maybe the third one here. So I have 4 equals 3 minus lambda. That means lambda equals minus 1, right? And then I'm gonna use that lambda being minus 1 to get the A, because then A is just equal to minus 1 plus 2 times minus 1. And that is just minus 3. All right? Yeah, I'm checking. Yeah, happy with that. So we got A. Now we do the same for B, right? So yeah, not hard now. B31 equals the same thing. They're going to have different lambdas, of course. Okay, so again, well, probably the same actually. Wait, not the same, sorry. So we're going to look at the third component again. So 1 equals 3 minus lambda. Lambda equals 2 this time. And then we're going to use that to solve for B. So B, the top component, equals 2 plus 4 lambda being 2. And then that's going to give us 8. Right? So we solve for A and B. That means A equals minus 3 and B equals 10. All right, for part A. Part B. Hence find vector AB. Vector AB. So vector AB is just OB minus OA, right? So OB is just the thing we solved there already, which is 10, 3, 1 minus OA. OA is just minus 2. A is minus 3 and then 4. Okay, that's AB there. Not too hard. It's going to be hard for the last one actually, the highlight. Okay. So 10 minus minus 2 is 12. 3 minus minus 3 would be 6. And then 1 minus 4 is minus 3. That's it for AB. Okay. Part C. The point C has coordinates 4, 7, minus 2. Find the size of angle CAB, given your answer in degrees to 1 decimal place. CAB. So CAB, right? CAB may be looking like that. I don't know. Hang on. A and B on the line. We're going to use that. A and B. And then C is maybe somewhere here. Okay, we're going to use this diagram later. Maybe I'm going to move point A closer to B. Okay, let's do that. Like that. So CAB, right? CAB. So it's this very guy here. That angle there. So we should get vector AB and vector AC. Yeah, vector AB and vector AC. If we want the actual angle there of CAB. So we haven't got vector AC. We already got the coordinates of C. So let's find vector AC first. So vector AC is just C minus A. So it's just 4, 7 minus 2 minus A, which is already minus 2, minus 3, 4. Right? We got it earlier. Yeah, so that is just what? 4 minus minus 2 is 6. 7 minus minus 3 is 10. 2 minus 4, 2 minus 2 minus 4 is minus 6. Yeah, just that. All right, that's it. So now we then do dot product. Okay, so I'm just going to go like theta equals arc cos. Yeah, it's just from the formula. So the dot product on top. Dot product between AB and AC, so AB being 12, 6 minus 3, dot product with AC, 6, 10 minus 6, and divided by the modulus of both vectors, AB and AC. So AB is going to be 144 plus 36 plus 9 times the other modulus. Just going to move to the left a bit. Okay. and then here would be the modulus of AC, so 36 plus 100 plus 36. Okay, and that will be it. So I'm just going to do everything in one go here. Get in degrees, right? So I'm just going to change the mode here first. Be careful. So arc cost fraction. So the top one is 12 times 6 plus 6 times 10. That's the dot product there, guys. Plus minus 3 times minus 6. That's just 3 times 6, right? Because the minus disappears. Divided by square root 144 plus 36 plus 9. And then on the side here, we also have times another square root 36 plus 100 plus 36. That's it. Yeah, so that is just 33.7 degrees. That's it. I think that's fine. Now the last one is the highlight, of course. Let me shrink down the whole thing. So part C here, it is mentioning another new point called point D, right? Called point D. And point D is going to make so that the area of CAD is twice. So let's try to think about that. So this is point A and B again. And C is not on the line, but point D is on the line, L here, the only line we have. And then such that it's going to make like the area of CAD double that of CAB. Yeah? So how are you going to do that? Well, think about this carefully. And this is a very key fundamental you need to know. When you have two triangles, yeah? Maybe I draw like that. And let's say there are line constraints here. So let's say you're going to draw a triangle where the vertex will lie on the top dotted line and the base will be aligned on the bottom dotted line. However you're going to draw it, like it or not, they're going to have the same height here. Okay? Now, what's the point? Well, if you know that this is, say, 2, for example, and this is, say, 6, so the base of the longer one is 3 times that of the smaller one. That is going to mean that the area of the larger one will also be 3 times the smaller one, because the height is the same in both triangles. This is what's happening here. Yeah, bear that concept in mind. I'm just going to keep this so that you can check later here. Okay, just keep it on top here, maybe. Bear that in mind, because when you have a point D somewhere and you think, okay, how do you make what? CAD having twice the area of CAB? Well, again, we use that concept there because they share the same vertex, which is point C, right? So I'm going to draw one area first, CAB. Yeah, that's CAB. And another one, let's say point D is around here. Okay, if you draw the angle, the triangle CAD, which is the new one here, the red one. Do you see that because they have the same vertex, it's like they are constrained in that rail again, like a track. So they have the same height, like it or not. Because you can make this the base of the smaller one and this the base of the large one. They have the same height, perpendicular distance. Yeah, we make the rails like a train rails here, and the perpendicular distance from C to that line is the same. As long as they have the same vertex, they have the same height. So that's it. That means we know that, well, D could also be here, and you would make also, the same thing. So this length must then be twice this length to make the area twice as large. Okay? That's it. And that's the very important piece of logic there. You need to crack this one, because if you use algebra, it's going to be real work there. Well, you could try, but it's not going to be as easy as this. All right? So D can also be the other side I'm going to put here maybe, where AD is twice AB. On this side, well, AD is twice AB. Okay, so D can be either side. That means if we make vector here first, AD, let's look at the first case here, AD, yeah, AD going up, is 2 times AB, yeah? And this is a vector, relative vector. But in the other case, AD, down here, yeah, down here, must be 2 times BA, because you got to consider the direction as well. If you say AD equals to AB like this, well, it's not going to give you this one. It's going to give you this one already, which is what we wrote here already. So it must be AD twice BA. All right? So AD is also twice BA. Now, if you look at those two lines, they're actually slightly different. But do you notice that AB is just minus BA? Yeah? So that means I can put them into a single line and solve them once. So it's just plus and minus, because they can go either direction, right? And we're going to start from there. Yeah, I'm going to shrink this whole thing down. And that is the whole logic there behind this, to make it much easier. Okay, so we want the position vectors of D. So AD is just D minus A. So it's just OD, which is the position vectors of D, minus A, which is, what is A again? It was, what was A? Couldn't find A, so minus 2. A is minus 3, and then 4, yeah? That is just the vector A. And then plus or minus, here I'm going to put first 2 times AB. We already got AB, sorry, yeah? Which is 12, 6 minus 3. There. Okay? So OD is then plus or minus, what is this? 24, 12 minus 6 plus minus 2 minus 3, 4. So you're going to get 2 possible answers, right? But I'm just solving everything at once here, like all at once, just to save space actually, to make it efficient. So we're going to get one of them, OD being, so I'm going to do the plus first. 24 plus minus 2, I get 22. 12 plus 12 minus 3 is 9. And then minus 6 plus 4 is minus 2. And the other one is just minus 24 minus 2 minus 26. Minus 12 minus 3 is minus 15. And then minus 6 is 6. Plus 4 is 10. There you go. So those are the 2 vectors. Position vectors of D. If I didn't do any arithmetic wrong, that should be the right answer. Okay, and you should know how to do this one. Next one, let's do this. P4 October 2024. Relative to the fixed origin again, point A has coordinates minus 10, 5, minus 4. Point B has coordinates minus 6, 4, minus 1. Straight line L1 passes through A and B. Find a vector equation of L1. Well, this one is classic and easy, so you just do, maybe you can do R of L1, R equals, you can just subtract one from another. So I'm just going to do minus 10, 5, minus 4, minus 6, 4, minus 1, and then plus lambda. All right, wait, hang on. That should be the thing here, actually. Right, that should be the vector B there. And then this I'm just going to put minus 10, 5, minus 4. So just pick one point to make it a vector A, and then the direction vector, you have to find the relative vector. So that's just going to be minus 10, 5, minus 4, plus minus 10 minus minus 6 is minus 4. Yeah, and 5 minus 4 is 1, minus 4 minus minus 1 is minus 3, right? That's it. Okay, the line L2 has equation that where P and Q are constants and mu is a scalar parameter. Given that L1 and L2 intersect at B, okay, find the value of P and the value of Q. All right, so they intersect, right? So we're just going to equate them, yeah? So minus 10 minus 4 lambda, this is part B, sorry. 5 plus lambda and minus 4 plus minus 3 lambda, yeah, and then equate that to the new line, which is 3 plus 3 mu p plus, minus 4 mu and q plus mu. Okay, because they intersect, there should be valid values of p and q and mu and lambda, right? So let's see, what can we solve first? Okay, seems like simultaneous here, guys. So we're gonna go for, hang on. Okay, oh, they intersect at point B. All right, I almost forgot that. That's minus 6, 4, and minus 1. So that has to be, minus 6, 4, and minus 1. Okay, so actually we can use this to that first to solve for the lambda and use lambda to find p and q, right? So let's use the first one. So minus 10 minus 4 lambda equals minus 6. That means lambda equals 1, right? No, minus 1. Yeah? So 4 lambda equals minus 4, lambda equals minus 1. So we're going to use that to solve for the p and the q. So I'm saying 5 plus lambda being minus 1 equals the second component there, p minus 4 mu. Ooh, I haven't found mu. Hang on. I need to find mu first. Let's find mu first. So we say 3 plus 3 mu equals minus 6. So mu equals 9 over minus 3, which is minus 3. Yeah. And then we use that to find p. So p, which is the second component, p minus 4, mu is minus 3 equals 4. So p would be 4 minus 12, which is minus 8, yeah? And then q plus mu again, which is minus 3 equals minus 1. That means q equals 2, right? Just solve all that already. Yeah, so it's a very subtle information there that they intersect at B. If you didn't see this, you're doomed, because I didn't at first. Okay. Now part C. The acute angle between L1 and L2 is theta. So acute angle, we got to be careful. I'm going to shrink everything first. Yeah. Part C, right? So L1 and L2, when we get the vector equation already, we can use what's called the direction vectors. So we're going to use that and do the dot product thing. Again, I'm going to do theta equals arc cos and all that again. So the dot product between the two is just 3 minus 4, 1. And then the other one would be minus 4, 1, minus 3. And then the absolute here, which goes like, so 9 plus 16 plus 1 times 16 plus 1 plus 9. Okay, they are the same length actually. Okay, so what do we have? Sorry. Arc cos again, that's already in degrees. Fraction. So 3 times minus 4 is minus 12, minus 4, and then minus 3. Okay? And that is your square root of 25, 26, and the same, right? So it's just 26 there, both of them. Okay, that's it. Yeah, just checking. Yeah, both 26. So that comes to be 136.950, blah, blah, blah. But you want acute, right? So that's going to be, if I minus 180 there, I'm going to get an acute angle, so I answer as a positive. All right, so the last part in vectors. Just shrinking this down first. Given that the point C lies on L2 such that AC is perpendicular to L2, define the exact length of AC, given your answer as assert. All right, so whenever you see a new point being introduced and it's on a particular line, you have to make use of the vector equation, right? Point C here is just, on the line, this line right here, but we don't know what it is yet. Yeah, and then after we know what it is, we can find AC and its length. But it may not be that hard. I just think you need to draw this out first, and I do suggest you do that. So line L1 and L2, they intersect, right, at B. Let's say that's L1, this is L2. They intersect at B. Oh, sorry. So line L1 and L2 intersect at B, and then point C lies on L2. Let's say that's point C. Yeah? And then what do we have left? Okay. AC is perpendicular. So A was on L1, wasn't it? Yeah, A here was on L1 because we created L1 from A. So A must be on L1. And then it's also saying here that AC is perpendicular to L1. Right? Sorry, L2. So let me make the diagram make more sense there. So AC is perpendicular to L2. I should have that. There you go. Perpendicular. So if you draw it out, you see clearly that this is just a right angle triangle. It's a trick question. So Katoa. Yeah? We want to find AC. So let's make that X maybe. And we need to just find AB because we already know the acute angle between L1 and L2. So that is just the theta we just got earlier. So you see, if we know AB, we know X. That is a lot easier to do all the algebra. I mean, I know that some of you might prefer doing it like, subbing in AC as the vector equation and then find AC and do the dot product. You can do that, but that's going to be a lot of algebra there. Okay, so we just want to find the length of AB first. Just going to be that. I think we already got it earlier, didn't we? What was AB again? AB, I think AB is something to do with this because we subtract A and B and then we got that, right, earlier. So that's going to be 16 plus 1 plus 9 again, and that is root 26, right? Yep. Okay. And then so here we have X equals sine theta times root 26, isn't it? Because X over root 26 is sine theta. It's this theta here, and so is opposite over adjacent, if you like. Actually, I don't do that, but there you go. Just make it more relatable to you guys. So sine of the 43 there, 0.0 times root 26. And I'm just going to use a machine here. Yeah. So sine 43.0, okay, times root 26. So that is just the answer, guys, for AC. Oh, giving your answer as a third. I'm doomed. Hang on. Let me get back to... Yeah, we need to use the cos value here again. So, if cos is that, well, how do we make a sine? We want a sine, right? So sine is just 1 minus, using identity there, 1 minus 19 over 26 squared, and then square root. That would be the value of sine, right? So 1 minus 19 over 26, is it? Okay, squared. So that's horrible, third there. So we have 3 root 35 over 26. Okay. And then here we need to plug that in. They will cancel, I hope. No, they're not canceling. Okay. Yeah. That's sine, right? So it's 3 times root 36 over 26 times root 26 here. Yeah, and that is just the answer there if you multiply everything. So that will be simplified third, right? Okay. Okay, so it's 35 times 26 in the third. And I think we can't really use any factor to simplify that. So it's going to be 3 over 26 times square root of 910 for that AC. Okay? I think I'm gonna go with that. All right, so that is the end of the vector part and also the end of the whole compilation here as of the time of recording. Of course, guys, if you see any harder one than this, just comment and I'll make sure I maybe do a short. If a short can't cope with the length of the video, maybe it's just a short video, and I'm gonna like attach the link to the video in this description. So let's grow this video together, yeah, this compilation I mean, and I hope that was all useful. I'll see you in the next video. Good luck with the exam.